Right, off we go then. Welcome everybody. It's so good for PHPBelfast to be back again. 7 long years. 7 years in this industry is a lifetime, it really is. So many things change, and yeah, it's about time we got everything back together again. So thanks so much to Darren for putting the wheels in motion here. Thanks to Used Cars and I as well. This is a great space. This is fantastic. It's by far the best space we've been in for doing any PHPBelfast stuff before, and yeah, really, really good stuff. So thank you. Thanks everybody for attending. So, clean coding. What is this all about? Oh, actually, do you know what? Before we do this, let me just introduce myself. That'll be the best thing to do, wouldn't it? My name is David Frame. I'm a lead engineer at NBC Sports Next. Actually, a team within NBC Sports Next called BRS Golf. We work on golf course software, T-sheet software, the whole suite of products around that. Some of you have actually worked in BRS Golf before, Sports Next, so you're well aware of that there. But yeah, I've been with Sports Next now for about 6 years, and just sort of rising up to that lead level. So, there we go. That's my intro. Clean coding. What is it all about? It's best described by way of a pretty famous quote. Any fool can write code that a computer can understand. Good programmers write code that humans understand. So clean coding is a set of guidelines for writing code humans can easily understand and work with. So clean code, it's in the name, clean code. Where do those guidelines come from though? Anybody have this book? Yeah? Anybody read the book? I looked at the pictures, yeah, pretty much the same place I am with this one. This is by a fellow called Bob Martin, Uncle Bob, very famous in software engineering circles. He does a lot of conferences and things, has written books on developer practices and things like that there. And this is his kind of observations of the industry and the code that he's seen in the industry and how he feels that it could be improved, made more readable, made cleaner. It was written in 2009. It consists of a very slim 464 pages, of which that's about 200 pages too many, to be honest. The problem with the book is that it's very, very, very verbose. It goes down to, like, really it dwells on things very heavily, and that sort of puts you off it a little bit because you're like, get to the next topic. And there's a lot of common sense stuff in there as well that's easy to kind of gloss over and leaf over. The main talking points of the book can be easily summarized, and people have actually done that. So here's a GitHub repository, or gist, and it's somebody summarizing the book. Just going through the book, getting all the main points, turning points out, putting it onto a GitHub page, and there you go. That's clean coding. So yeah, there you go. That sort of demonstrates how inflated the book is when somebody's able to do that. So this talk then is based off some of the content of that book, plus a few of my own observations from 20 years in the industry. It's not an exhaustive list. It's not a set of instructions. It's just something to be aware of. Okay. The other thing is as well, do as I say, not as I do. Okay. This is a balancing act between implementing these guidelines and actually getting things done. You can get stuck with this sort of stuff. You can be looking at code thinking, is that perfect? No, let's spend a bit more time on it. Is it perfect yet? No, code doesn't need to be perfect at all. Okay? It needs to be good enough to read, understand, and ultimately work. So take some of these guidelines, apply them if you want. Don't go overboard with it. So the way this is split up, 2 sections. Part 1, style. Okay? So style. When I started planning this presentation, I noticed a pattern in some of the notes that I made. Many of the guidelines can be split into 2 categories, style and structure. Style-based guidelines make code look nice and easy to read at a glance. Structure-based guidelines make code easy to maintain and extend. Okay? There can be some overlap, so just bear that in mind. I'll point some out just as we're going. So let's start with some styling. Coding standard. Who uses coding standards? Yeah, everybody uses coding standards. We all sort of know what coding standards are. How to use them. If it's a new project, use the preferred or popular standard for your language and or framework that you're using. If you're working in PHP, PSR 12 is very well established. If you're using a framework, Laravel, Symfony, whatever, it has its own coding style, most likely based off PSR 12, perhaps some tweaks here and there. Use that coding style. If you're starting or if you're working on an existing project, use its standard. If you're unsure, ask. Go to another engineer, developer who's worked on that project, or a lead or senior or whatever, find out what the coding standard is, what they actually want you to be doing. Still unsure, match what you see. If you don't know what the coding standard actually is, just look at the file that you're working on at that point in time, assuming it's an existing file. What is the standard there? Is it using spaces for indentation? Is it using tabs? Is it two spaces? Is it using studly caps? Is it using underscores? Whatever, just match that style. So the biggest problem with this, and the reason the coding standards exist, is the code that's written with different standards in mind, different standards within one file. It looks horrendous. It looks really, really amateurish and horrible. If everything is kept under the same standard, then you know what to do. You know what standard to be using. You don't have to think about these things ahead of time. You just say, right, okay, this is PSR 12, I know what to do, blah, 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 blah. And then you can use things like static analysis tools as well to run through the code base and make sure that it is of that correct standard. So yeah, don't make standards. That's the main takeaway from the slide. Don't make standards. That's it. So, naming convention. Excuse me. Just check. Can everybody see this? Okay. Can everybody see the code? Okay. Oh, it's a little bit small. So, naming convention. Choose descriptive, pronounceable, unambiguous names. Don't abbreviate. We see this all the time with code. So we've got things like, see in this update function, let u equals user.fetch. What is u? If you ignore that user.fetch line and you're just saying u.zh, u.sv, what does that mean? U, what does that represent? SV, what does that function mean? Don't abbreviate things. It's way, way more difficult to come back to code later or have somebody else look at your code and figure out what the hell is actually going on with it. Next, variable's name should describe what it is. Function's name should describe what it does. This isn't really a hard and fast rule. It's more, again, just a bit like a guideline, but generally speaking, a variable should describe what it actually is. Function, if it's doing something, it makes sense that it should be called whatever it is it's doing. Be verbose with your naming, but not too verbose. So yes, have things like, user repository, fetch with name. That's fine. But if the naming that you're using for a variable or property or function consists of like 8 words, it's done to cut together, that's maybe a bit too long. So try to be kind of pragmatic about it when you're thinking about these things. Just want to touch on something quickly actually. So in this first point I said about choose descriptive, pronounceable, and ambiguous names, don't abbreviate. Pronounceable. That's an interesting idea when you think about it, because pronounceable names can be remembered more easily. Think about passwords. The easiest passwords to remember are ones that are words, phrases, things that are like easily, in the language, in your native language. These are the things that you remember easiest. So it makes sense to call your tokens within code readable, pronounceable names. Yes, and a particularly long variable function name, as I mentioned there, may indicate that it's also taking on too much responsibility. This is sort of overlapping with more structure stuff, but if a variable is called number of members with first name matching blah 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 blah, that's probably doing too much, or if you have a function similarly named to that there, that's probably doing too much. If it's more than 2 or 3 words, that's a good indication you should probably start sort of thinking about refactoring, splitting things up a bit. Replace magic numbers, strings with name constants. So if you're using this is kind of common sense really, if you're using a value of some kind, say, just pick for example a member type. Say you have a user type of one, where one represents a member of somewhere. User type one, rather than in your code doing if user type equals one, make one constant, call that constant type underscore member, whatever. Then you can read at a glance and see, well, that's what that's actually doing. I'm checking to see if this is a member, this user's a member, rather than this user is of type 1. So what does that mean? So yeah, use those name constants makes things way easier. Oh, this is controversial, this one. I like this one. Comments. Remember what you're told in school, in college, in uni about comments? Ignore all of that. Don't use comments. The reason is clean code is self-documenting. Think back to the namings again. If you're naming things correctly, if you're naming things and making things relevant, why do you actually need to comment code? The code is actually telling you what it is doing. You know, you're saying that a member has a first name of whatever. You don't have to put in a comment saying this user has a first name of whatever. You can see it in the code. If you name things appropriately, you don't necessarily need to comment. So there are occasional exceptions where you will need to use comments. Cases where things maybe you're using like a complicated algorithm or something that at a glance just doesn't make sense to people or seems quite hacky for whatever reason on maybe an older code base, where it really is beneficial to put a comment in for somebody else to come along and say, that's what that does, okay, I get it now, because the nature of the code is that you weren't able to do that yourself. So yeah, you can use comments from time to time, but not extensively at all, using sparingly. Another thing, avoid change-related comments. Everybody does this, including me, all the time. Put in comments saying df, date, this is what changed, or this is, WIP is a good one, or fix later, or to do, or whatever. Don't do comments like that there. Version control exists. We all use version control, Git. Some people might even use SVN, Perforce if you're crazy. So yes, we use it, version control systems, so use version control systems. That's where those comments stay, not in your code. Dot comments can still be useful. So above a method or a variable, property or whatever, if you're using a loosely typed language, which is sort of PHP, kind of, sort of, sometimes it is actually beneficial to have a dot comment above a method or whatever, just describing what that method does. If it throws an exception as well, have a little dot comment saying it throws whatever. It's really helpful to read at a glance, again, see what's happening, and it's useful to the IDE, because it will pick that up and be able to know that, okay, so this method throws an exception on type whatever. So yeah, dot comments quite good. Next, line lengths. This is kind of common sense again. Try to keep code within 80 columns. What's the difference between these two things here? What's going on here? You have to scroll right to see what's happening here. Break this up onto multiple lines. There's the same code. You can see what's happening. You don't need to scroll. Never exceed 120 columns. So yeah, keep code within 80 if possible. But if in doing so you're making it kind of difficult to read in other ways, resort to 120 columns, but don't go above 120, because at that point you're really just dragging the cursor along. Scanning your eyes downwards is more natural than scanning sideways. So think web browsers, newspapers, this was figured out many years ago. Going downwards, better than going across. Facilitates larger font sizes, split panes, portrait oriented monitors, etc. So yeah, again, if you've got code that looks like this here, you can ramp up the font size, make it a little bit more readable, if you prefer. It's just a personal taste thing. This gives you the facility to do that. This here, not so much, because you're going to chop even more off the right-hand side of the screen. Portrait-oriented monitors as well. Yeah, interesting idea. Just whip the monitor on the side so it's lengthwise. That sort of orientation, and you fit more of the code on the screen if it looks like this. don't jump through hoops. I alluded to this earlier. Don't go overboard with this here. 80 columns is fine. If you can get stuff within 80 columns, fine. Don't worry about going up to 120. If you're going to be like doing weird sort of, spaghetti code and stuff like that there to get your code to fit within 80 columns or 120, yeah, don't do that. That will actually end up making things worse. So there's plenty of places you can cut off code. You can see, like in this condition here, each part of the condition is just on a new line. Method call, function call here, the parameters are new lines. That stuff's easy. Other bits, maybe not so much. White space makes things more readable. Think paragraphs. Again, this is simple stuff. Paragraphs make text more readable, easier to consume. So use white space in code. Break things up. Like, does this look quite clean? Yeah, but if it was all bunched together, again, it would be harder to sort of visualize and understand at a glance the various components, the various parts and chunks of this piece of code. Use white space to break things up. Yeah, use the associate blocks of code, like I say. Stay consistent. Yeah, this is tricky with white space. It's hard to know sometimes when to put in a new line or when to leave a blank line and when not to. Common conventions are things like before a return statement. If you're in a function or a method, you've got a return statement at the bottom. Some coding standards would suggest that you actually have an empty line above that. But remembering to do that every time is kind of tricky. And then what if the return is earlier up in the method and stuff? And yeah, it gets a wee bit difficult. Try your best to stay consistent with it. It's not that easy. Okay. Yes, sorry. I was looking at my example, thinking that had white space. It does not. It's just because the line spacing is so large. So yeah, this has no white space at all between these various blocks. We've got like users at the top here, and then it's for eaching around them, and then we've got this like queue parsing or queue. It's pushing anything onto a queue and sending an email and whatever. It's all grouped together, so you don't really know what's going on. However, add in some white space, and now we've got chunks of things. Here's our sort of user stuff. Here's our queue stuff. Here's our caching stuff, send email, and then just a random exit statement at the end. It's all broken up quite nicely. Now, indentation. So, ignore the dubious code here. There is some of it throughout. Let's just use for an example. This overlaps quite heavily with structural stuff. In this case, we've refactored notify admin and notify user into send notification with a parameter. What am I talking about? No, sorry. Okay, yeah, I'll get back to that. So yeah, indentation, reduce the code path as much as possible. See this here? Look how deep this goes. Way in. You haven't scanned your eyes, left to right again, figure out what's going on. 2 deep, 6 levels deep at that point. Ways of getting around this, return early. If you can return early from a method, do it. That cuts down indentation again. Avoid else statements. Yeah, this is something. If your code, this is where the overlap with structure comes in again. But if your code is set up in such a way and kind of architected in such a way, you actually don't really need to be using else statements. And that again cuts down a bit of indentation. Obviously, within an else statement, you're indenting in to do that else block. If you're not using else statements at all, there's no indentation. I'd recommend sort of reading up on that a little bit. I can't go into the specifics of this here because it is kind of complicated. I'm not too sure myself. But yeah, it's all to do with the code structure. Remember, vertical scanning is better than horizontal scanning. Of course, yeah, you're reading down instead of across. And see also cyclomatic complexity, which is the sort of level of indentation, and that is a structural thing again. So I think the next slide is an example of me cutting down the indentation. Yeah, that's where I was getting ahead of myself there. In that case, yeah, we've refactored the code. We've changed this notify admin and notify user, these two methods, into a send notification function with a parameter. It doesn't move the problematic else into a new function. So you'll see there's still an else there. So with me saying, yeah, don't use else's, well, there's an else in there, I think. Or no, sorry, the else will actually be at a different level. We've just moved it to a different level of the code. If you follow through how this kind of works, you'd see it. But yeah. else's are difficult. So that was us for the styling. Sorry, I got a bit blurby there at the end. Part 2, structure. So, this is where we focus on structure-related guidelines. Interesting stuff. Rule of thumb, style guidelines involve changes to one file. Structure guidelines can involve changes to multiple files because you're kind of re-architecting stuff. You're maybe doing some refactoring, and that usually involves multiple files. So, how do we do restructuring, or how do we maintain structure within an application? We keep it solid. So this is Uncle Bob, and he is showing off some magic blue pills there, and also talking about the solid principles. Five parts of this. Does everybody know what solid is? Are you sort of familiar with solid principles? Useful stuff to know. It sounds complicated, kind of is, but a lot of it is common sense without even realizing it. So, there are a subset of many principles promoted by Bob Martin himself in his design principles and design patterns paper. He didn't come up with a solid acronym, that was independently devised a few years later, but he did come up with the concept. So SRP, single responsibility principle, there should never be more than one reason for a class to change. Well, that's kind of self-explanatory. So if you're changing a class, it has to be for one particular reason. Yeah. There we go. OC, or open close principle, software entities should be open for extension but closed for modification. That comes into things like composing code and stuff rather than using inheritance. LSP, that's called substitution principle, designed by contract, which basically means use interfaces. ISP, many client-specific interfaces are better than one general-purpose interface. A good example is here is, say you have an interface for a class or a set of classes that you're using, and it's called sends email and informs users. So two different actions are controlled by this interface. There's no point in doing that. Have an interface called informs users, and have a separate interface called sends email with whatever interface is defined within that, with whatever method stubs you may need. And you can just use those interfaces wherever you need. You can combine them together. It all works. So that's the idea behind interface segregation principle. Dependency inversion principle depend upon abstractions and not concretions. That's not quite the same as dependency injection, if you know what that is. But yeah, I'm not going to go into too much detail about this stuff because it is all that ruling. So let's go into more interesting things. Classes, keep them small and specific. So if you have a very, very long class, hundreds of lines long, that's probably a warning sign that that class is doing too much. Try to cramp it down, split it up into multiple classes if needs be, all doing their own individual topics or individual actions or methods or whatever. That promotes single responsibility principle. Again, if you're cutting things down to their bare units, the bare units of functionality, single responsibility, that means one class, one unit of code is doing one thing. That's SRP. Realistically, classes grow over time, you can't avoid it. You add more functionality to classes as the need arises. They get bigger. It's just part of engineering. It's our object-oriented engineering anyway. Avoid long lists of properties as well. If you have a class with lots and lots of properties, like this one's okay, there's only 3 of them, but I've seen classes with like 20 or 30 properties, and it's like, well, what is this class doing about 100 different things? Again, that's a bad sign, it's a side of a code smell. Avoid nondescript service classes, booking service, tea time manager, etc. I'm bringing my golf noise stuff here. This is kind of an interesting one as well, nondescript service classes. That's kind of resorting to, like we're using object-oriented programming here, using these service classes is kind of resorting to functional programming because you have a class name called, something like booking service, and you're putting logic about bookings into that. That's not really an object. It doesn't really make any sense. The class isn't describing what it's actually doing. It's just a booking service. Well, what does that mean? It can mean absolutely anything. So try to avoid those types of, those kind of nondescript class names, and keep your classes using this single responsibility principle of only doing one thing. So an alternative is something like a booking manager class or a tea time manager class, you might have tea time might need to be locked for certain users. Well, you would have a tea time locker class, or tea time lock class, tea time unlocker class, things like that there. The class should actually describe what it is, or the class name should describe what it is that the class is doing, in the same way that a function should, in the same way that a variable or a property should. Functions. Okay. User ID for, first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that. Functions should not be 100 lines long. Functions should hardly ever be 20 lines long. I'm sure you've got lots of functions in your code that are more than 100 lines long. I know I certainly do have. But again, it's bringing it back to this whole idea of code should only really be doing one thing. A function should be doing one thing, class should be doing one thing, etc. The smaller you can keep a function, the better. If you can extract it out, use refactors to extract out certain aspects or certain parts of the function into another function, and then into another function, and then maybe into a different class. Great. That's splitting up your code. That's making things smaller. Making things smaller tends to be better. Use your IDE for this sort of refactoring as well. When you're talking about extracting methods and stuff, if you're using PHP Storm or any modern IDE, really, they have tools for doing this sort of stuff and plugins. That has really, really strong, comprehensive suite of refactorings that will do this stuff for you and to make sure everything's still working correctly in the background. Yeah, this also promotes single responsibility principle, as I keep harping on about. Like classes, these grow over time. Again, you can't avoid it. Functions just get bigger. You may have the best possible intentions, you may have a function that's 10 lines long, you're thinking, brilliant, I've got all my functions 10 lines long, until a few weeks later, a few months later, you need to make changes to this code to add in a bit, and suddenly your function is like 30 lines long. It's just the way of it. Always think about refactoring. Blocks of code may be extracted into separate functions. I just said that, so I'm going to develop. Strike a balance. Yeah, again, quite important to be realistic about this stuff. How far can you go with splitting things up, splitting classes up, splitting functions up, renaming things? You can fall down a rabbit hole and you can fall pretty deep. You have to know when to stop. And it can be tricky to know when to stop sometimes. So yeah, try to strike a balance if you can.
Sorry. Just on your point there, like 10 or no longer than 100 lines long.
Yeah.
Is that 100 lines of real estate or 100 lines of functional code?
100 lines of functional. Yeah, and just ignore white space as part of that there. White spaces wouldn't be considered as part of that. So, okay. Okay, 4 slides left, I believe. Function parameters. Yeah, you can sort of see what's bad and what's good here. It's pretty obvious. Remember naming convention, first and foremost. It should describe what it's doing. Or the parameters should describe what they're doing. Ideally, functions should only have one parameter. That's nuts. Ideally, functions should only have one parameter. Think about that. How many functions have you seen with one parameter? But again, if things are pulled down, if things are extracted out and split into their tiniest, smallest components, that kind of makes sense because the function will probably only need one function, if any, to do what it is it's supposed to be doing. 2 is okay. 3 is stretch. Try to make use of entity and parameter objects. If I'm remembering correctly, I think, Darren, you had to talk about this?
I did, yeah, value objects.
9 years ago or whatever it was. Value objects, yeah. So instead, if you have a look at this bad ad code, where I'm passing through forename, surname, age, street address, time, postcode, yada, 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 well, what does that actually represent? Looking at that represents a person's details and an address. So create a class called person with properties of forename, surname, age, and create a class called address, the street address, town, postcode. And now I've got 2 properties where 2 parameters we're passing into that method instead of 6, whatever it is there. That's how we can simplify things. And again, that's splitting things up into new classes and functions and so on. Avoid Boolean parameters. Oh yeah, okay. Avoid Boolean parameters. 9 times out of 10, when you see a Boolean parameter, it is changing the functionality of a function. or a method. It's changing what it's actually doing. It's putting it into a different mode of operation. So say you have a, say you take this example here, this good ad where we're adding a person and an address to this array called this items. Maybe we want to have a operation that, I don't know, for sake of a silly example, but lowercases all of the properties of the person before it gets added onto that array, or onto that property array. So we think, okay, how are we going to do that? We don't want to do it in the calling method. So let's just add a boolean here. Let's just put a boolean at the end of this method saying, make person lowercase, right? And then you do that, we just have a bit of code above that says it loops through all the properties on that object and sets it to lowercase. Fine. But not really fine, because what you're essentially doing is changing the functionality of that function. You're doing something different. Two modes of operation, you're doing two separate different things. And that's something you'll see that's actually quite common. If you see these built parameters and functions, they're doing a different path, they're using a different path through the function. Better to have two different functions. And you can extract out some commonalities between them, and maybe into their own method or own function, and avoid using those booleans. You have a function that describes exactly what it's doing, not including a parameter that also needs to describe what it's doing. So yeah, there we go. Dependency injection. Hopefully most people are familiar with dependency injection. This is not part of clean coding, but it's worth a mention here anyway, because it really does lead to cleaner code. It's not the same as dependency inversion. Remember I said earlier when I was going through the solid principles, dependency inversion, yada yada yada. That's dependency injection is not dependency inversion. Similar sort of thing, but not the same. Your backend framework, if you're using Symfony or Laravel or just about any framework these days, in any language, will likely have a dependency injection container implementation as part of it, just baked in. So use it. And what is dependency injection? If you don't know, this is a really nice quote. $25 term for a 5-cent concept. Dependency injection means giving an object its instance variables. So yeah, that's all there is to it. Rule of thumb, only entity objects should be instantiated within a class, service object should be injected. So if you have something that represents like almost like a tangible item, say for example, here again we're looking at, let's see, no, I can't see a good example now, never mind. Say you have like a user class that represents a user, that's fine. You can instantiate a user class in your code, in a class, or a user object within a class. Absolutely fine, you're just creating something. On the other hand, if you have using the bad example from before, if you have like a user manager class, that's the service that does something with that user, maybe it stores it in the database or manipulates it in some way, whatever, should you be creating that object within your class? No, you should be passing it in through dependency injection, passing it in as a parameter of your class or as a property of your class. You can see it happening here, where we have API client interface, API client, T-time repository interface, T-time repository. These are service classes that are being passed into the constructor of my T-time locker class. These are all learning lots and lots about BRS call when I teach you here. So yeah, they get passed in and they can be used. You don't need to create these anymore within your code, which makes your code much more rigid, easily testable, less prone to error by reducing coupling. So it means that this T-time locker class no longer actually needs to know what an API client is. It doesn't need to know anything about that object. All it needs to know about is this API client interface that this API client implements. So long as it knows what this interface is, you can pass anything that extends to that or implements that interface into this class. The class doesn't care. It only cares about what the interface is. So that's like this reduction of coupling between this code and other bits of code. And makes testing easier. Now, not so much these days. Mocking frameworks and things can do fancy things and inject properties and stuff, but generally speaking, doing a dependency injection makes testing easier if you do test, which hopefully everybody does. Promotes a closed principle as well. So yes, without going too much into the detail of this here, it's if you have a class, like an API client here, and you have a new version of this, you create a new version of the API client class that does something different. Don't go to that URL, by the way. That does something different. Rather than having to change the name of the class within your code, again, so long as your new implementation is just passing, or it's just implementing that API client interface, this code doesn't need to change with your new API client class. It doesn't need to change at all. You just pass in the new version from whatever it was that was invoking or instantiating this class. Composition versus inheritance. I like this. Inheritance is a very important component of OOP. But misused inheritance results in tight coupling and segregated interfaces. Yeah. So the idea here is you should try and avoid using extends where possible. If you have a chain of things like X extends Y, extends Z, extends blah, 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 suddenly your code is not really rigid again and very, very susceptible to issues creeping in, and it's something you really need to try and avoid. So yeah, try and avoid it if possible. Here's an example of composition. So class automobile, where we have private vehicle. So we've got a property called vehicle as part of automobile. Not declaring the type of that, probably should. Public function construct vehicle, passing in this vehicle object. And then accelerate. We're saying public function accelerate. So we accelerate our automobile. We don't know what the vehicle actually is. It could be a car, it could be a van, it could be a bus, it doesn't matter. We're just saying call this accelerate method, which in turn is called this move method on the vehicle. What we could have done instead here is have our automobile extend vehicle, have a vehicle class with the sort of basic functionality of vehicle, excuse me, and have automobile extend it. That's inheritance, but it can lead to issues. So try to use composition instead. And if you're all curious about what this is all about, definitely go and read up on it a little bit. There's lots written on this. I'm going to use an interesting example here. I've been talking to some people about like working in Simply's SD and Tybus and so on in the past. Back when we were sort of trying to modernize the CMS that was used there, I came up with this awesome inheritance tree where I would have a MySQL handler as our database abstraction layer. That would be extended by our website class, which would have information about the website, like maybe we'd have the name of the website, it would have some metadata, for example, we would put in the meta tags. Website class would be extended by a page class, which would have some information about a page, a web page, for example, maybe a template that it's rendering. That would be extended by a subpage class because web pages have subpages, our websites have subpages. Oh, and then subpage would be extended by, subpage would be extended by the About Us page. So suddenly we've got like 8 classes in this this level of inheritance hell, and suddenly now we decide, okay, what if we need to have like an About Us section between subpage and About Us, or above subpage, or whatever? How does that all work? It all just breaks down and everything just falls apart. So yeah, don't do lots and lots of inheritance because it leads to issues. I know from experience. So composition promotes looser coupling and code reuse. Composition is more resilient to change. Composition keeps classes small and concise. Inheritance is more fragile, but generally easier to read, follow. Yeah, like when you look at this here, it sort of doesn't really make a whole lot of sense at a glance, because if you were just having automobile extend vehicle, that's immediately, okay, I can see what's happening there. This is more sort of in the realms of like design patterns and stuff, and it's not just as easy to understand right away, but it's better code, I think. Okay, design patterns, talking of which, okay, let's talk about design patterns very, very quickly. Design patterns promote clean code in the right situation. Realistically, you only need to be aware of a handful. You've got design pattern manuals out there, the Gang of 4 book, with lots and lots and lots of these patterns listed, and nobody ever uses any of them, apart from like the big 4 or 5 maybe. Singleton, don't use that, be aware of it, don't use it. Factory is very, very common. Decorator is also very common, very useful. Adapter, and what else do we have? Frameworks tend to use them to promote reuse and extensibility. You'll see design patterns used all throughout frameworks and things. Going back to the whole like Java days and stuff, the Java Standard Library or whatever it was called, it was full of design patterns, which made it a nightmare to navigate. But yeah, it's frameworks use them a lot because it does promote that whole idea of extensibility. Just to touch on these very, very briefly, singleton is usually better achieved through dependency injection. If you're using singleton pattern to create one instance of a class and one alone, you can do the same thing with dependency injection, do it that way instead. Factory is useful for creating objects without having to specify or even know the exact class. You usually see them combined with switch statements. A decorator is useful for changing a class's behavior at runtime. So you've got a class that does something, you want that class to do something else while the application is running. You can use decorator for that. Adapter is useful for making different classes adhere to the same interface. A good example of adapter is travel plug. So you've got your standard 3-pin UK plug. You go traveling to the continent or America or whatever, you need an adapter to convert that into 2-pin or whatever it may be. There's your adapter. It's just taking one sort of input and converting it to a different, or output or whatever it would be. Yeah, one sort of interface converting it to another. That's right. Ta-da. There we go. That was a bit of a whirlwind. Thank you. That was a bit of a whirlwind. I know I sort of strayed off topic a little bit at times there, and it did get a bit dicey, I think, at some points. But if you're at all interested in the book, definitely pick up the book. I did say obviously that it's quite heavy and a bit weighty, and yeah, it's nice to leaf through because you do pick up things just by picking it up and having a quick oh right, okay, that's a nice idea. Or go to that GitHub page, but just with the summary information. This is something that just branches off out into its whole big thing. You'd spend years searching stuff on clean code and figure out the best practices, so don't go too far with it, certainly. But if you're at all interested, there's plenty of resources out there. Okay, anybody have any questions?
Tabs or spaces?
What day is it? Thursday? Yeah, very opinionated. I actually would prefer tabs. Yeah. From what I've seen, I know it's very controversial, but I just feel like when you're looking at code in like GitHub or something like that, or pull requests, it feels like tabs just render a bit more cleanly. So yeah, it's tabs. But only if all tabs to do it. Anybody anything else? Yeah.
Thanks ever so much for the talk. Can I just clarify, the first PHP group in 6-7 years, whatever it is, was the first bit of code JavaScript?
It was.
Oh, yeah.
And this presentation?
Yeah.
I think everybody lost today with JavaScript on the front.
Right, okay.
Was it part of this style section?
Yeah.
It's coming.
Next one.
Oh, John's
The principles still apply. Same stuff, PHP, JavaScript. Yes, so there we go. Yeah, bit of a slip up, but there we go. Yeah,
Is there
you find it. I put that in there. Thank you.
Is there a second clean code book out there?
There's clean code and there's clean coder.
Oh, right.
So clean code is more to do with the code itself. Obviously, clean coder is more what you want, how you become a better developer and what it means to be a professional developer and things like that. There, there's a lot of hot air in that book. Yeah, Bob Martin tends to have quite a lot of hot air when he's going off about things, like saying you should be spending like 4 hours a day of your personal time learning your trade. Okay, Bob, do you have a wife and kids? How does that work? But yeah, it's sort of a bit woolly, but there is some interesting information in it. Okay, definitely Bob Martin, look into some of his conferences and things. He's on the conference circuit, and he'll have 2 or 3 different topics that he sort of loops around, but they're all pretty good. He has ones on clean coding and other bits and pieces as well, and he has quite a nice presentation, so it's quite enjoyable to watch. Okay, pizzas.
Pizzas are here.
Perfect.
Well done, David.